can you hear me?
Yes.
Sorry for being late. Yeah. Uh, so we'll be spending like 45 minutes on coding exercise. I will give like last 10 15 minutes for feedback.
Yeah, sounds good.
Cool, cool, awesome. So yeah, here's the first question. So yeah, so basically we'll spend like try to solve a couple of coding questions, and
Mm-hmm.
later like I will share some feedback like how it went.
Mm-hmm. Okay.
So yeah, so this is the first question. Like you have an array of string, you have to group the anagrams together. So two string are anagram of each other if they have
Mm-hmm.
same characters. So for
Mm-hmm.
example, nat and tan, these are the anagrams of each other. Eight, eat, tea, these are the anagrams of each other. So basically, you will have one single list of string, and you have to return the list
Right.
of strings.
Right. Okay. Let's see. So, okay, that's good. Okay. Okay. Mm, okay. Let's see. Mm, okay. So I think one one way I could do this is hmm, let's see. Eat. Hmm. Hmm. So one naive approach would be go iterate through strings, iterate through the input, and then create some sort of dictionary where you have eat, and then here uh, the value would be uh, um, the indexes where the indexes that are sort of um, the same anagram, right? For example, uh, wait, um, so for example, we have eat, then we have eat. Eat is at zero, right? Oh, sorry. Yeah, eat is at zero. Then eight was at the third index, and t is at first index. So, mm, right, and then yeah, do have a dictionary where you have um, like yeah, at each level the indexes with the anagrams, right?
Mhm.
And then same thing with nat, same thing with bat, right? If bat will only have zero, and then nat will have like what? Nat is a fourth fourth index, and 10 is at the second index. And then we iterate through the dictionary and say, okay, um, you know, like for each level, for each
Mhm.
entry in the dictionary, uh, append a new a new sub array, or like not a sub array, but like a new append an array
Mhm.
to the array, like with like we have a
Mhm.
result array, and then append
Mhm.
bat, append nat, and uh, all the words, all the
Mhm.
anagrams together, and that would be my first approach. Um, mm, let's see, but I mean the thing with
What
this is, oh sorry, go ahead. Yeah,
what would be the complexity of this one?
yeah. So for the complexity would be, let's see, mm, let's see, or so okay, so I would have to iterate through strings once, and then let's see. Wait to do. I was thinking, okay, in order to check the so let's say I check. Let's see. Oh, what happened? What? Oh, um. So let's say, okay, I iterate through the strings. So let's see. Iterate through input once, and then each one. Let's see. Let's see. N log n. Right. But let's see. Counter. Wait. N times. Okay, so what I was gonna do is so sort every string so that like, okay, we're gonna go to eat, right? I mean, if the dictionary is empty, then we put eat, and then I sort the word t, and yeah, so sorting t would take n log n, and we're doing n log n for each and every word. So right off the bat, it would be n squared log n, right? Because I'm doing n log n every, like, for every word, and then let's see, n log n, n squared log n, and then I would have to do this. Oh yeah, but yeah, so yeah, it would be at most n squared log n, because all other operations are smaller, right? Like iterating through the dictionary is smaller than n squared log n, and appending the words is smaller than n squared log n. So yeah, so it's of n squared log n. Yeah. But I guess I can do better. Or would you like me to go through the optimization, or do you want me to code this approach?
I'm thinking like I'm okay with this. Like let's try to
Okay,
this.
for sure. So let's see. So yeah, so I'm gonna use Python. So we have like group anagrams, and then we have our input string, or just strings, and yeah, that's our input, and then we need to generate a new dictionary. Anagrams dictionary, just dictionary, and then we have the result array, and then for word in strings, we say something like so we have sorted word equals sorted word, and then if sorted word wait let's see, so we have anagrams dictionary equals anagram dictionary sorted word equals anagrams dictionary dot get. So what this does is, um, return the value associated with the key sorted word,
Mm-hmm.
and if there's nothing at that, if that key does not exist, then just return zero. Um, and oh wait. Oh, never mind. I need to yeah. I'm not yeah. I need to return the index. So this would not actually um in let's see. Do I need a let's see.
So
Let's
can you
see.
help, like, what get conf sorted word comma zero gives? Like, if, okay, it's a default value if it is not there, is it?
Right. So actually, so yeah, this is. I mean, I need to append the I need to append the index. So this would not work. Yeah.
Mm-hmm.
Yes. So for each word in strings, actually, let's do while because I need the index. So let's see, I equals 0 while I is lower than length of strings, right? And then word is equal to strings I, and then we say something like, yeah, if uh, sorted word not in um, anagrams dictionary,
Mm-hmm.
uh, then we say, we have uh, anagrams dictionary sorted word equals I, else, oh wait, so we will need to put like, a list here, because we are collecting uh, all the indices, um, and then else, if it exists, then we say, oh yeah, we append, we sort of do this. We append the dictionary to the existing. Um, dot append this. So yeah, now we have the dictionary here, right? Mm, Now we need to generate the output. Mm, so for this, we go, let's see, for key value, we can do for word, let's see, word anagrams, indices, lists, or indexes.
Do you need to increment the I?
The I, oh yeah, my bad, yeah. Otherwise, it would like just run infinitely, yeah. Yeah, right, thank you. Um, and then for each word and list in, um, we have anagrams dictionary dot items. So we get each level, right, of the dictionary, and we say, okay, let's see, okay, and then we're gonna iterate um, through each index in indexes list, right? Uh, uh, indexes list, and then we're going to say, okay, um, let's see, we're going to have like a current or like temporary 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 group anagrams group, yeah, this, and then we're gonna append the anagrams, or rather the words at the index, right? So append the so we have strings index, right? Yeah. And then when it's done doing that, then we're going to append uh, temporary anagrams group to result, right? Result.append this. Right. Mm, right. Mm-hmm. For index in indexes list. Yeah. Okay. And then after that, we just return result. Uh, mhm. Yeah. Uh, yeah, that's yeah, yeah, that would be my answer. I can optimize it. Maybe the thing is, sorting is one of the most expensive operations here. Mm,
Mm-hmm. Mm-hmm. What do you think we
so
can still have?
right, instead of that, we can like use the counter method and
Mm-hmm. Mm-hmm.
count how like the frequency of each character
Right.
instead. Yeah. So let's see. Mm, mm, but then wait. Mm, I mean counter. The one thing about changing sorted, like instead of sorting it,
Mm-hmm.
mm, we would have to use counter.
Mm-hmm.
Um, but counter returns a dictionary, right?
Mm-hmm.
Um, a dictionary of you know characters and the
Right.
frequencies. So
Mm-hmm.
that is we cannot put that as a key in a dictionary because a dictionary is editable, right? It's mutable, right? So keys cannot be mutable. So we should like think of something like yeah. Let's see. Uh, do 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 do.
Can you create your own counter using?
Oh yeah, yeah we could, and we could return maybe hmm, let's see. Instead of a dictionary, we could maybe a tuple. Uh,
Mm-hmm.
that's that's the one. Wait, what? That's yeah, one of the few immutable uh, data types. So yeah. Uh, see. Yeah. Okay.
Cool. Can you go with the tuple?
Sure. Yeah. Of course. Let's see. Do. Yeah. Okay. Yeah. Okay. Let's see. Word. Let's see. Let's see. Let's see. Okay. So we have word, and then instead of sorted word, we say or we can yeah we can create um a new a new function here like counter, and then we get word, right? And then yeah, so we say okay for uh, character in word, uh, let's see. Mm, let's see. Okay. So, let's see. So we have um. Let's see. Oh wait, can we? Huh. I'm wondering if we can put a dictionary inside a tuple. Um. With that, yeah. Mm, let's see. And I mean, because in theory, the tuple itself um is immutable. Um. Right. Mm,
Mm-hmm.
okay. Yeah, I can try that. That would be faster. Mm, so here. So okay. Counter. Okay. Character or like yeah. C character counter
Mm-hmm.
equals counter. Um. Yeah. And then put that into a tuple. Like yeah. Um. This and this. Mm, and then if character counter. Let's see. Oh wait. Oh yeah, I need a comma here uh to make it a tuple. If it's a tuple with just one item, I need to put the little comma here. Um, and then do if um if character counter uh not in anagrams dictionary, right? Um, then anagrams dictionary this oh character counter. Yeah, sorted word. Yeah, and the key would be the tuple itself, like the counter, the tuple with the counter. So yeah, um, if character counter not in anagrams dictionary. Mm, yeah. Okay. Uh, character counter. Yeah, I think this is better. Um, word. Yeah. Okay. Yeah. This should be faster. Yeah.
Cool, awesome. Let's move to the second question.
Hmm.
I'm just pasting it on top. Let's say like you have a sorted array and two integers k and x. You have to return the k closest integer to x in the array. For example, if you look at Example number one, k is equals to 4 and x is equals to 3. Closest to 3 is like 3 itself because it has 0 distance from 3. So 3 goes there. 2 and 4 both are closest to it, are at distance of 1. So both goes in. Um,
Mm-hmm.
Out of like 4 and a 5, only, and then like either you can include 1 or a 5. Both would have been, both could have been included. But in that case, like we'll choose the smaller one. So 1 would be included, 5 won't be.
Mm-hmm.
And if you take a look at second example, closest to -1 are like 1, 2, 3, and 4 because 5 is like far more further than -1. So yeah, it's not necessary that x will be the part of array.
Mm-hmm. Okay.
So yeah, so given an array k and x, you have to return the k closest k elements which are closest to x.
Okay. Okay. Um. Okay. Interesting. Mm-hmm. Okay. A. Oh wait. Okay. So we're looking for the k closest integers to x. Okay. X
Right.
x is 3, and then we're looking for the 4 closest um, to 3, right? The 4 closest to 3. Okay.
Mm-hmm.
1, 2, right? 3 and 4. Okay. And then in this case, an integer a is closer to x uh, than an integer b if. Okay. Okay, so that's why 3 is closer to itself because it's 0, right? Like
Right,
3 minus
right.
3 is 0. Yeah. Okay, makes sense. Yeah. Okay, good. Okay, right. Makes sense. Makes sense. Um, makes sense. One,
And if
two.
like there are two choices, we will use the smaller one. Like like 1 and 5 both are at distance 2 from
Oh,
3,
right.
but 1 is smaller than 5, so we
Right.
choose 1.
Makes sense. Makes sense. Okay. Hmm. Uh-huh. So, uh, can we assume that we will not get repeated integers?
Mm, that's a good question. Like there could be repeated integers.
Oh, we will not get repeated integers?
We can get repeated integers.
Okay. 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 Hmm. Yeah, that makes sense. Okay. Hmm. Okay. What if we have, for example, 1, 2, 3, 3, 4, 5? Like.
Yeah, so in that case, like both 3 would be included, right?
Mm-hmm.
It
Oh,
will be
okay.
like 3 comma 3, and these one will go away.
Okay. Okay. Hmm.
And if like there would have been this case, like 2 comma 2 comma 3, then this would have been like 2 comma 2
Mm-hmm.
and 3 comma 3, because like you will choose these two rather
Mm-hmm.
than these four, that four.
Mm-hmm. Mm-hmm. I see. Um. Interesting. And for example, in this case, right? Like, uh, because here is a is 3 and x is 3, so this is
Mhm.
0 equals 0, but like they're both equal, so we just
Yeah, you can
put
include
both.
them. Yeah,
We just put both. Okay. Mm, okay. Interesting. Well. Let's see. So my approach here would be something like, um, let's see. Mm, yeah, we would need to look for X first, right? Uh, oh, and can we assume that X will be inside our input array?
No, you can take a look at second example. X is
Oh
minus
yeah.
1.
Oh my bad. Yeah, you're right. You're right. Right. X. Right. 4 plus 1. 2 plus. Okay, makes sense. Yeah. Okay. And can uh, can we assume that we'll have like, let's see. We'll have, let's see. Um, that we'll have at least k integers in our input array.
That's a good question. That you can assume. Yeah, k is less than equals to total number of elements.
Okay, that makes sense. Good. Thank you. Okay. Okay, so we say something like, hmm, let's say, okay. Hmm. Yeah. So okay. So I'm gonna we have to look for X. Oh no, wait, no, not X. Let's see. Um, hmm. So when yeah, we need to find for X, but in case it's not in X, like we need to look for the place
Mm-hmm.
where it's supposed to go. Uh,
Mm-hmm.
given it's there, right?
Mm-hmm.
Uh, so I think we should perform some sort of binary search and
Mm-hmm.
determine the place,
Mm-hmm.
the index where it's supposed to go, right?
Okay.
And start from there. Uh,
Sure.
perform perform a binary search
Mm-hmm.
to find uh, uh, index uh, of x, right? Um,
Mm-hmm.
and then and then start. Let's see. Uh, let's see. So it should be. Let's see. Mm, I think yeah, we should start looking from left to right, so that
Mm-hmm.
whenever we append a new integer, it's in order, right? It's sorted um, in ascending order.
Mm-hmm.
So in this case, let's say we got -1, so we start with uh, I mean in this case, if we don't have anything available to the left, we just start you know with the right and say 1, 2, 3, 4. We just we just we just keep appending numbers until let's see. Um, let's see. Mm, let's see. How can we guarantee that? Uh, let's see. Mm, see. Huh. Hmm. See. Because I'm having trouble for like I was gonna say, we start from left to right in this example, right? But what if we have something like minus 100, minus
Mm-hmm.
20, right? Minus 20, um, right? I mean, this part of the array is
Mm-hmm.
closer to x than this side, right?
Right.
Right. Uh, let's see. Mm, let's see. Hmm. Yeah, that's a bit tricky. Um, here.
But do you know the range
Hmm.
in which, from which you will get the your k numbers?
Ah, that's a good question.
Like once you find the index.
Once I find the index,
Mm-hmm.
yeah, so it should be, mm, uh, like up to, huh, like whatever we have, for example, uh, let's see, that's a good question. Uh, hmm, yeah, 0, wait, um, 1, see, mm, like you mean the difference between like a and minus x? Like what's the maximum and minimum ranges of this?
No, like means that if you are at like this index 3, right?
Right,
So you have either
right,
just two choices, right? Either you will go to the left or you will go to the right.
yeah,
Mm, Can like out of those two choices, how you will determine which one to pick?
right. Yeah, so we compare 0 with the one to the right,
Mm,
uh, and say, okay, yeah, we perform this operation or this operation, and then we
right.
append,
Mm,
right? Then we append whatever the shortest, like whatever the closest integer is.
mm,
So
mm,
we do that, and
mm.
then maybe we can have pointers or something like that. We move our pointer to the right,
Right,
and
right.
uh, then we compare x with the one to the left.
That's a good, yeah,
Uh,
that's a good time, yeah.
yeah, okay. X with the one to the left, and say, okay, if left is, yeah, and then we compare maybe our right pointer with our left pointer, right?
Right. If the difference of
And
that pointer with X is like whichever the difference has a smaller difference, yeah,
yeah, exactly, yeah.
then yeah, yeah.
Oh yeah,
Cool.
we can have two pointers. Okay, yeah, okay.
Mhm. What would be the overall complexity?
So yeah, so would be. So this is log n of log n, uh, and then mm, and then do, 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 and then we iterate to this like at most one
Mm-hmm.
time. So it's log n. Uh, oh yeah, so it would be linear, right? Because it's log n plus n, but then n is greater than log n, so it's just
From
linear,
where
right?
this n is coming? From where this n is coming?
Oh, n is the number of integers in the array.
Why it will be n? Wouldn't it be the key?
Why is it n? Or
Yeah, why it will be n? Won't it be the key?
right? So
Because like you
it,
won't be going through all n elements. You just add at max k elements, right?
right. Okay, you're right. Yeah. Uh, yeah, you're right. One, two. Yeah. So yeah, it's
Cool.
k at most k elements, right? So yeah. Okay, makes sense.
Mm.
Uh, so it would be log n plus k in this case. No.
Mhm. Mhm.
Uh, okay.
Cool. Yeah.
Uh, so should I implement it or should we? Is there like, or did we run out of time or?
Yeah. Yeah. We have like 3 4 minutes. Like maybe if you want to,
Okay.
you can assume that you have a binary search. Don't worry about binary search. Just
Okay.
implement the comparison part where
Right. Right.
you. Mhm.
Right. Okay. So in this case, we have the array and say something like, we get the index from the binary search, um, and then yeah, binary search, uh, yeah, say x array whatever, um, x. Um, okay. So we have left pointer and right pointer uh, equals 0, and then or actually index, yeah, index index, and then we have result here, and then we have something like, hmm, let's see, if, and then we do this, right? If absolute of let's see, array left pointer um, minus x
Mhm.
is lower than absolute of array uh, right, where is it? Yeah, right pointer,
Mhm.
hmm minus x, um, mhm, if true, or yeah, or they're the same, so it's just or they are the same, then just uh, append, uh, append. Mm, let's see, we append. Let's. Oh wait. Oh okay. Wait. Oh see. Oh yeah, we append the left pointer, right? Mm, append array. I mean, we append the left uh, pointer. Uh-huh.
Cool. I
Um,
think, yeah, I got an idea like you would be able to implement it.
yeah, yeah,
So let's move to the feedback part of it.
sure.
Yeah, so I think like for the first problem, you use the good naming convention. You use like meaningful name for method name. Only thing like I think like could have been done better is your complexity analysis. You could have used two different parameters. The n is number of
Uh,
strings in a list, and m means size of a string, right? These are two different things, and then it would have been like m into m log m.
yeah,
Yeah. So basically, you could have clearly did like this complexity analysis with two different
yeah,
parameters rather than like
yeah,
confusing them with just one. But
yeah.
yeah, I think like it is a small thing. Another
Hmm.
small improvement which you could have done is when you are iterating through some range, right? I think like
Yeah,
for loop makes sense, like for I is equals to 0 to I in a range, like you could have used for loop where like
yeah,
you won't miss incrementing part. So when you are in iterating through some range of values, you could have used the
yeah,
range with a for. So
yeah,
yeah, that these are the only two things which I think could have been done better. Apart
yeah,
from that, like you were correctly you correctly identified the bottleneck of your implementation. You also suggested that rather than using sorting, you can use a frequency map, so that's a good that's a good thing. You also mentioned about like that Python does not allow mutable dictionary. We also identify the workaround by using that into the tuple. And like your code was easy to follow. Yeah, so that was really good. And like when we started the second question, your attention to details was really great. You asked really good clarification question. You asked like whether there will be duplicates. You came up with a test case with a duplicate and clarified what could be the output.
yeah,
You also asked like if will there be at least k elements. So those were the really good questions, and that shows the attention to details, right?
hmm,
With
yeah,
some hint, you were able to come up with a solution using two pointers. Yeah, and you also rightly applied binary search looking at the array sorted, right? I think like
yeah.
you could have articulated your two-pointer approach better. I think you
Mm,
required some help to communicate that idea, right?
hmm, hmm,
So that would be uh, that's one thing I think like you can work on.
hmm,
And another thing is like you could have just like first method you could have used some meaningful name for function rather than just a solution. But maybe it was a time crunch which forced you to do that. So don't worry about it.
hmm.
So my question would be like when you are practicing on lead code or something, right?
Yeah,
Try to
yeah.
create a try to create a comment section where you try to write your approach in a plain English word so that you get in a habit of communicating, like thinking or articulating your solution, communicating your solution well. So that will help you to get that block away, where
Hmm.
which we thought, which you saw with you trying to communicate two-pointer thing. So yeah, rather than just coding in a lead code, also try to write down your approach in three, four sentences, like so that like you you uh, you get in a habit of like articulating your solution well, analyzing
Hmm.
details before jumping into implementation.
Yeah,
Cool, but yeah, I think like overall it was good. There is a really good, great improvement from previous interview. Based on this, like it would have been an higher call. Yeah,
Great, great. Thank you for the feedback.
Cool, awesome. Yeah, I think like yeah, just try to like write down your approach before writing the code while
Yeah,
practicing. That will help you to articulate your solutions well. Apart from
right.
that, like I think like you ticked all the tick boxes. Like you did everything right. So yeah.
Yeah. Oh, great. Thank you. Appreciate it.
Cool. Cool. When are your interviews starting?
Uh, so I have one on Monday.
Mm-hmm.
Um, but but yeah, I'm still in college. I'm still an
Mm-hmm.
undergrad. So
Right.
yeah, I wanna be ready for next year, right? Like the upcoming
Mm-hmm.
the one I have on Monday is it's fine, but I really want to focus on the one next year. Like yeah, but
Sure. Cool. Awesome. Yeah. All the best for your journey. Yeah.
for sure. Thank you so much.
Yeah. Thanks. Bye bye.
Bye bye.